And so let's go ahead and look at the last sort of mechanism for functions where we're interacting with data. And this is passing as a pointer. Passing as a pointer is very useful for when you're not wanting to take in a whole variable either by copy or by reference. It's very useful for if you're wanting to only interact with a certain member, or you're not going to be using every single member inside of your struct. So, for example, if just say if we have a bunch of more variables in this struct, for example, int c equals 2, int d equals 4, int e equals 10, and just we have like just say we have like 200 more variables, but in this function we're only going to be working with maybe 3, 4, 5, a very small amount of these. We don't need, that's a lot of, it's a lot of data to have 200 of these variables. So if we're passing by copy or passing by reference, that we might not even need all 200 of those variables. We might only need 3 of these or 4 of these or 5 of these for that specific function. That's where pointers become very useful. They point to very specific areas of memory. So we don't need to pass a whole sort of copy of this type in, or the whole object, because we're not going to be doing anything with all those variables. So let's look at pass by pointer. So func, and then my struct, then we do asterisk, and then arg, and then here we're going to be able to interact with these members through a pointer. And so here, if we wanted to interact with MA, we do arg, and then use the pointer MA. And then let's just say that we want to print this out. It's the cout, and then arg, and then we use the arrow operator, and then m underscore a, in this case the member. And then let's do another one. Let's say arg m underscore b, and that will print sort of our members. And again, this is very useful for when we're only wanting to work with specific members of a struct, instead of, because here if we were gonna work, if we were gonna interact with all of these, then yeah, it would make sense to pass in something by reference or something by copy, because we need all this. But we don't need, because we're only passing in, we're only interacting with MA and MB. We don't need to work with all these other members right here. So that's where passing by a pointer can become useful for when we only need specific parts of it. And so let's go ahead and create the function. And so let's go ahead and call this for a variable, so we can see what that's going to look like. So if we do struct var, and then do func, and then with var, and then there are two ways of calling this, either through the ampersand operator, which in this context, it is the address of operator. It will give us the address of var, wherever var is stored in memory. Because if you remember, a pointer points to an area in memory. And so what it points to is a memory address, and the ampersand, when it's passed in through the function parameter instead of the argument here, if it was passed in with instead of this ampersand, then it would be a reference passed by reference, and we would not need this ampersand. But because the argument is passing as a pointer, when we actually call it as the parameter, then we need to use the ampersand operator to signify that we are passing the address of it. Or the other way you can do this is C++ has a function, a built-in function that will return the address of a variable, and that is the address of, and then that will pass the address of our variable, and that will do the exact same thing as using the ampersand operator. So whichever you like more, you can use. So let's go ahead and run this. And as you can see here, we are printing the m underscore a member and then the m underscore b member through a pointer.